here we go. So questions over the homework? I had you go 1 through 26, basically. Anything off that? Okay. The answer is -1. I will do it real quick. It was number 20. It was -1 to the -8. So what is being raised to the -8 in this problem? 1, right? Not -1, because the -1 is not in parentheses. The power is only impacting the 1. Okay, so let me do that. Let me get this out of here first. I think that's a scratch. Yeah. Okay, so I'm going to rewrite this then. I'm going to pull that -1 that's sitting in front of the 1. That's kind of weird, but there's like a -1 sitting in front of a 1 to the -8. Okay, so that negative is kind of in front. Now, what is 1 to the -8? What did we say 1 to any power was last class? 1, right? So this right here turns into a 1. And then -1 times 1 gives us -1. Okay? And that's it. Any others? Okay. Let me show you. This is number 23. Yes, go ahead. 1 to any power is 1. Yep. Any power. It turns out, even if it's not an integer, even if it's a fraction, does not matter. Yep. Okay. Now, -1 to any power is something else. Okay. All right. All right. So number 23 was 6 to the -4 times 6 to the +4. And that's a multiplication right there, isn't it? Okay. So what we have here is same base. When you have the same base, what do you do to the powers? You add them up. So you get 6 to the -4 plus 4. And what is -4 plus 4? 0. 6 to the 0. And we said last class that any number raised to the 0 is 1. That's why it turns into a 1. Now, I should kind of talk to you real quick about that. We said last class, and I'll put it on top right here, that any number raised to the 0 is equal to 1, right? Except, there's only one exception, 0. 0 to the 0 is actually undefined. It's kind of beyond this class. You study that a little more like in a calculus class. 0 to the 0 is kind of like trying to divide by 0. Remember, division by 0 we say is undefined. You can't divide by 0. Well, you can't raise 0 to the 0. And the reason why is because anything raised to the 0 should be 1, right? But 0 itself wants to be 0. So it's kind of like this weird tug of war. And what happens is we just wind up being not able to define it. But when we have 6 to the 0, that's 1. So as long as that base is not 0, you're good to go. Okay, anything else? Yes? Number 5. Okay, so if it's numbers 1 through 6, let's wait. All right? Is that okay? Because, like I said, I kind of jumped the gun there. It asks you in numbers 1 through 6 to match the problem with what property was used. And the only properties we saw were the first two, A and B, on the multiple choice there. Now, I apologize to you because I didn't catch that when I assigned the problems. But what we'll do now is we'll pick up and we'll talk about the rest of those properties now. All right? Unless there's any other questions on the homework. Okay, now what we do have from last class, okay, I'm going to do a quick summary. What we determined last class was a couple things. X to the negative n was 1 over x to the positive n, right? That was one thing we determined. The other thing we determined was what I just said, x to the 0 is 1 if x is not 0. So any number to the 0 is 1, except 0 to the 0. That doesn't work. And then we had this rule, x to the n times x to the m is equal to x to the n plus m. And this was called the product rule. And what was the most important thing about the product rule? What did we have to have in order to just say add up the exponents? You have to have the same base, okay? You have to have the same base in order to be able to add the exponents. Just like we had 6 to the 4 or 6 to the negative 4, we could put those together. Okay, so that's it. That's what we have right now. Those are like the three things we have up to this point. So today we're going to add a couple more rules. We'll finish up this section. But on our schedule, we're supposed to be doing a different section today, and then Tuesday is supposed to be a review, and then next Thursday is supposed to be our first test. What we're going to do is we're not going to do that additional section. What we cover today is going to be the last of the material. Tuesday will be a review, and Thursday will be the exam. So the exam's going to stay a week from today, but we're not going to have that additional section. I think it was Introduction to Functions or something like that. So at the end of today, that'll be it. That'll be all the material. So all the homework that we've done up to this point is what you should study to get ready for the test. Come here on Tuesday, I will have a review to hand to you, and we'll go over that review, and then Thursday, hopefully, you'll be ready. Okay? All right, so the next rule that we have is called the product to power rule. Product to power rule. I'm going to put that on the side here, product to power rule. And then along with that, we're going to do the power to power rule. I'm going to put that underneath it, power to power rule. Okay. So these are going to be two distinct rules. We'll call them, let's call them Rule 4 and Rule 5. Now, I haven't given you the rules yet, but let's talk about the wording of it. You have a product to power. Here, power to power. Okay, what's a product? Well, when I say take the product, what's the operation's multiplication, right? Multiplication. So this is saying, what if you have multiplication between two things and you try and raise that to a power? Okay, so the product means multiplication, we have multiplication, and then this means raised to a power. So let me write down to the left of that what it would look like. I have a product, first of all, two things being multiplied. Let's say x times y, right? Two different things being multiplied. There's my product, and I want to raise it to a power. Both of them to a power. So I'm going to put them in parentheses and raise them to a power. The question is, what does this become? Okay, and so the rule says what you're allowed to do, it's not distribution, that's not the technical word for this, but you are kind of just going to distribute the power to both of these. So what you'll have is this, x to the n, y to the n, and still multiplication between them. So what happens here is you start off with two things that are in parentheses with what operation between them? Multiplication. If that happens, then what you can do is you can apply the power to both of the factors. Each of them gets it, and then you can figure out what each one is. I just want to really stress to you that the operation between the x and the y is multiplication. If that was an addition, this rule would not work, okay? Now, I'm going to do the next rule underneath it, and then we're going to do some examples. All right, and I'll mix the types of problems up. So the next rule says I have a power to a power. So that means that I'm going to have something raised to a power, and then I'm going to raise it to a power again. The question is, what would happen? So I'll put that underneath here. I have something to a power, an exponent, and then raise to a different power. So what happens if I take something to a power and raise it to a power again? Sorry, my handwriting's kind of scribbly there. Raised to a different power. So let me try and write this down. Let me see. What would something to a power look like? How about x to the n? Isn't that something to a power? Okay, and now I want to raise that to a power again. So I'm going to put it all in parentheses, and I'm going to raise it to a different power called m. This turns out to be x to the n times m. Oh, will someone help out there? Can you all kind of clear the way a little bit so Miguel can get through? Thank you. Oh, no, it's okay. Thanks for calling and letting me know. Okay. All right, so we have something to a power, that's the x to the n, raised again to another power. All right? I think there's might be space there. Yeah. You'll have to ask if you're willing to share. Okay, I think the best way to work these is just do some examples, start to see the differences, okay? So let's go ahead and start out with our first example. How about this? 2x to the third. You tell me, which property am I going to use? Am I going to use property 4, where it's a product to a power, or am I going to use property 5, where it's a power to a power? 4? 5? So we all... What's inside the parentheses? 2x is a what? It's a product, isn't it? Isn't inside the parentheses 2 times x? Yes? So I have two things being multiplied, a product being raised to a power. Therefore, I will use the product to power property, or rule. Do y'all see that? So according to the rule, what can happen is that exponent, the 3, will be applied to each one of those factors. So in my next line, I'm going to write equals, and then I'm going to write 2 raised to the third times x raised to the third. Does everyone see that that is the property 4 above? The n goes to both, so the 3 goes to both. But what is 2 to the third power? 8. And x to the third, well, x to the third is just x to the third. I'm just going to leave it. No, because that would be turning a power into multiplication. You could write this, but we don't normally write it this way. I mean, x cubed means x times x times x, but we like to write it as x cubed instead because it's condensed and nice, and so we wouldn't do that, but that's what it means. Okay? So that's property 4. Let's try another one. I'm going to write it down, and then you see if you can figure it out, okay? And then I'll finish it off. Oh, he did that to you. Really? Really? See if you can figure out. Start off by trying to determine what rule you're going to use, then apply the rule, and then try and finish it out. Give you a little hint here. Anybody have it? If you think you have it, let me know. Just raise your hand, and I'm going to come see if you do. You think so? Where's it at? Okay, be careful. What does this mean? Okay, think about that again. And then this, we don't want to leave a negative exponent. So that's kind of now you're doing stuff from the homework last night or the night before. Yeah, you could do it this way. That's fine. Yeah. Now you need to tell me what each one of these is. Yeah, but you're on the right track. Now you don't have to pull the -1 out. Just so you know, you could leave it on the -4. But I'll address that when I get to this, when I show everyone. You would have to drop the -4 down to the bottom and leave a 1 on top over -4, and then that's to the second power. Yes. Anyone else think they're on the right track here? Good. Excellent. Yes. Okay, this is right. This is good. This right here needs to be changed so it doesn't have a negative exponent. So bring it down. Okay, I think that's enough. Let me work through it just to show you. There's several approaches to this, all right? But what property am I going to use? Product to power, again. Now, the two things that I have being multiplied, now watch this, you have to be real careful with this. I have a -4, right? And then I have an x. So I have two distinct things being multiplied. The rule says that if I have two things being multiplied, I can take each one and raise them to that power. So I'm going to rewrite this as -4 to the -2 times x to the -2. Now, I left something off intentionally to see if you can tell me what I need that I'm missing right now. The parentheses around what? This -4. See, because isn't the -4, I'm going to raise that whole thing to the -2? So in order for me to say that, I have to have the parentheses around the -4. So I need to put parentheses here. Y'all see where I put them? Any questions on that step? Now the next step is to figure out what each of those are. And so this goes back to your homework from last time. If you have something to a negative power, we don't want the negative power. That means we drop it down and make it positive power. So I have to rewrite that one right here. Becomes 1 over, what? -4 to the +2 times, what does x to the -2 become? 1 over x to the second power. Do y'all see that? Man, shaky today. Must be all the caffeine. Okay, so what do we have here? What's -4 squared? That's -4 times -4. Negative times negative is positive. So we get 1/16 times 1 over x squared. How do you multiply fractions? Straight across. So let me multiply those two straight across. 1 times 1 is 1 over 16x squared. I think this problem is a good example of why it's so important to do your homework before you come to class and to get all that squared away. Because if you were still having problems with this, then of course the rest of the problem is going to be difficult for you if you haven't resolved that. But if you've done enough of them, you did the homework, you've practiced, then I think hopefully you're comfortable enough to do that step and then just move through and finish it out. So kind of math, you probably already know this is kind of like a pyramid, right? You don't build the top before you build the bottom. You have to build your way up. Okay, let's do another one. I'm going to start a new page. Oh, you know what? Hold on. I don't think I'm ready to do that to you yet. Let's do that. Sorry. 5xy to the third. In fact, I know I'm not ready to do that to you. So this is different than what we've seen in what way? Can anyone tell me how this is different than what we've done so far? We have two letters. What's the operation between those things in there? Multiplication. So it's product, right? But now we have a product. We actually have three things being multiplied instead of two, right? Well, when we had two things in there, each one of them got the power, didn't it? Well, the extension of that is if you have three things, they all three get the power. If you have four things, they all four get the power. If you have 10 things, all 10 get the power. So it's just an extension of what we've already done. So all this turns into is the 5 to the third, which turns into 125, the x to the third, and the y to the third. Now 5 to the third power is 125, right? It's not 15, right? Don't make that mistake on the test. It's a common thing, but it's one of those things that you will lose points for, right? 5 to the third is 5 times 5 times 5. Sometimes we get ahead of ourselves and we just think too fast and multiply it instead. What about the x and y? It's still times. We just leave the x cubed and y cubed, because x cubed, y cubed is just whatever x cubed, y cubed is. There's nothing I can do to fix it. Had it been a negative up there, then yes, I would do something with it. But because the powers are positive, we're happy. So this is it. All right. All right, let's do another one. How about 2 to the negative 3 to the negative 2? Yeah, now what property are we looking at? The fifth one, right? Because what do we have inside the parentheses? Is that a product? No, it's a power, isn't it? What's in this parentheses is something raised to a power, as opposed to what we had up here where it was just products, multiplication across. So the inside the parentheses is a power, and what are we doing to that power? We are raising it to another power, right? So we have a power to a power, and in the previous notes, the fifth property says if you have something to a power, and then you go and try and raise it to a power again, all you're going to do is multiply the powers together. So you're going to, whatever's being raised inside that x, the base, whatever the two powers are, you just multiply them. Yes? So it would be yes, we're going to take, I'm going to get my highlighting out of here. What we're going to do is we're going to take the powers that be, right here, and we are going to take them and multiply them together. Negative times a negative is positive. So we still have, the base doesn't change, it's 2, but now it's to the positive 6. And 2 to the positive 6, 64. You see that? Sure. Try another one. Yes. Mm-hmm. Like that? Let's see what happens. So is this property 4 or 5? 5, power to power, right? So anytime we have power to power, we multiply the powers. So what I'm going to do here is take a look at that 4, the negative 2. I'm going to multiply them, right? Multiply those together. What is 4 times negative 2? Negative 8. Don't raise it, right? You're multiplying. So this will be x, the base stays the same, but now it's to the negative 8. Now, can I leave my answer like that? Or should I leave my answer? No, I've been told by the math gods to not ever leave negatives in exponents, all right? So get rid of it. How do you get rid of the negative? 1 over x to the 8th, positive now. Now it's a positive exponent. I can't do anything to that, right? X to the 8th is whatever x to the 8th is, and so I box it up. Forgot to box my 64. Okay. I'll give you one more of these, and then what we're going to do is we're going to start doing problems where you have a mixture of properties all working at the same time. So there will be a little bit of something in there and a little bit of something else, and you have to just make it all work out. Okay. How about -4 in parentheses, but already in parentheses, to the 3rd all to the -1. Now that just looks weird, right? All those parentheses. So inside the, when you go all the way inside the parentheses, you have a -4. You can't do anything -4, right? It's just sitting there. But I'm taking -4 and I'm raising it to the 3rd power. Agreed? So the -4 is kind of like the x sitting here. I have x being raised to a power, but then all of that's being raised to a power again. So I've got power and power. What do we do when we have power, power? Multiply. So I'm going to take the two powers, 3 and -1, multiply them together. And what's my base? -4, right? And I need to keep it in parentheses, because we've talked about whenever you have negative numbers raised to power, it's very important to keep the parentheses there. But the power is what now? -3, right? So I multiplied 3 times -1 to get -3. Now, I don't ever leave things with negative powers, so I'm going to rewrite this as 1 over -4 to the 3rd, but what am I missing here? Parentheses around that -4. Now, in this problem, it's not going to make too much of a difference with the parentheses, but if it was an even number like 2 or 4 up here, it would totally change things, because remember, hopefully last class you remember I did a problem with parentheses and without, and I showed you there are 2 different answers. So we have to keep the parentheses with this until we actually do the cubing of the -4. So what's -4 cubed? What's negative times negative times negative? So -4 times -4 times -4. The first two multiply to be +16 times -4. So -64. So 3 negatives multiply out to be a negative. So the bottom is really just -64. 1 over -64. All done. Okay. So as you can see, I mean, it just starts to get kind of ugly here. And if you don't think it does, then how about take a look at this one? 4 to x squared y cubed, all of it squared. So what property do we have here? We have power to power. You see that you've got powers like x squared, then you're going to eventually want to raise that to the second, right? Like this is x squared, but you're going to want to square it, and then you've got like a y cubed, and you're going to want to square it. Okay, well, let's back up for a second before we get too ahead of ourselves. Don't we also have product to powers, to a power? Yeah? So we have both here. We have both properties. So the way that you should do this is first, let's do the product to power property. That means I'm going to look at this as having 1, 2, three distinct products, right? Do you agree I have three things that are being multiplied? The product to power property says I can apply that power to each one of these, right? I can take that square and put it on each one of those. So my next line, watch what I write. I have the 4, right? That needs to get what? Squared, right? 4 needs to get squared. Now, do I need parentheses around the 4 here? No, because it's not negative, so I don't need to worry about, carrying the negative sign or not. So I can just leave it as 4 squared. Now times, now I need to take care of that x squared. What am I supposed to do with the x squared? Well, yes, but I'm going to square it, right? So watch how I write this. I'm taking the x squared. I'm going to square it. I'm showing this step. Even though that is going to turn into x to the 4th, I want to show you that step. So do you all see that that's just the yellow one here being squared? And then times, what's the next one? Y cubed, and it needs to get squared. So that's my third piece. So there are my three products, right? My 3 parts of my products, we call them factors. Those are my 3 factors. Each one of them, I came in and squared them. Y'all see it? Now, let's go work on those. 4 squared is just the number 16. X squared is our power to power property. So we multiply the powers, right? 2 times 2 gives us 4. So I'm going to multiply those 2. That gives me x to the 4th. And what am I going to do on the y cubed squared? Multiply again, because power to power. So 3 times 2 is 6, right? And that's your answer. If you want, you can kind of group them up together a little bit. They look kind of like they don't like each other. Let's get them close together. Does everybody see that? Combination of 2 properties in one here. Well, it depends on how you would do that. I would need to make sure that you're doing the 5th property correctly. Like, if you just look at that, like some people get to the point, like, if you've done hundreds of these, where you just look at that and you know that that's 16x to the 4th, y to the 6th. I mean, you just do it all in your head. So if you're saying that, do it all in your head, that's fine as long as you're doing it correctly. Now, if you're coming up with the wrong answers every time, then you need something to go off of. This is the way I would do it. Product to power first, then power to power next. I'm going to do one more, and then I want to see what you can do on your own. I'm going to give you one to work on. All right, how about -3, x to the -2, y to the 4th, all raised to the -2. Do you see inside the parentheses that we have products, factors? Go see them? We have 3 of them again, don't we? We have our -3. We have our x to the -2. And we have our y to the 4th power. So there's our three factors. Each one of those products, right, is being raised to a power. So I'm going to use the property that says if I have a product to a power, that power gets applied to each one, doesn't it? So I'm now going to take that power and apply that power to all 3 of my factors. So who wants to help me out and tell me, just by speaking, what I should write next? Okay, -3 in parentheses, good. Raised to -2, good. X to the -2 in parentheses again, like that. Raised to -2 again. Times y to the 4th in parentheses, sorry, I jumped the gun there, to the negative 2. That's it. That's each of the three factors, all getting the negative 2 power applied to them. Are my colors a little too childish for you? Okay, I don't want to be too childish, but it's there, so we'll use it. All right. Who's going to tackle the negative 3 to the negative 2? Who wants that? Any volunteers? Tell me what this is going to turn into. Okay, 1 over, I agree with that. 1 over what? Negative 3 to the positive 2. Good. So all we did here was we took something to a negative power, we rewrote it so it had a positive power, so we had to drop it down underneath the 1. Follow? Now the next one, you have some choices here. Bless you. You could, if you wanted to, try and look at this as being something to a negative power and doing 1 over it. But what's even easier than that is just that you have something to a power, don't you? So can't you just multiply those two powers together right now? And what would it become? Positive 4. So if I multiply these two, because I have a power to a power property or rule, this becomes x to the 4th power. And last, on the outside there, how do you want to do that? Same thing, meaning multiply them? So just take the 4 and multiply times negative 2? Sure, why not? That's a power to a power. So that's a negative 8. So I have y to the negative 8. Which is now going to be in my next line. So we'll work our way across again. What's 1 over negative 3 squared? So negative 3 squared means negative 3 times negative 3 is 9. So I have 1/9. Well, be careful, because when you take negative 3 squared, what you mean is negative 3 times negative 3, right? So that's 1 over 9. And then the x to the 4th is still just x to the 4th, isn't it? But then the y to the negative 8 becomes 1 over y to the positive 8, like that. And now I need to put all these together to get a final answer. So we need to talk a little bit about numerators and denominators here. I have two things living in the denominator, which is the bottom. I have a 9 and I have a y to the 8th. The x to the 4th, because it's not written as a fraction, automatically lives in the numerator. So your answer is going to be, or if you like this, you could actually write the x to the 4th as x to the 4th over 1, because anything over 1 is itself. And now you just look at all the way across the numerators, would give you what? X to the 4th. And then across the denominators, multiplying 9y to the 8th. We made it. It's obvious that there's plenty of room for error with this, right? But once you get used to it, get comfortable with it, take your time through it, you'll start catching on. All right, time for you to, it's showtime, okay? Let's see what you can do on your own. Can I move on? I need more paper here, so virtual paper, I guess. Let's do this. I'd like for you to do these examples. How about 9 to the negative 2 to the negative 1. 6x cubed to the negative 3. And then the grand finale, negative 3 x to the 4th y squared z to the negative 5 all to the 4th power. I do want to point out something on the last one once you get it written down. There's actually a couple of things I want to point out. The first thing about the last one is that you have a product there inside the parentheses. How many factors do you have, though? You have the negative 3, the x to the 4th, the y to the square, and then the z to the negative 5. So you actually have 4 of them, but that's okay because if you follow the rule, it should do the same thing that happened with 3. Now, the other thing I want to point out, and you don't have to do this, but as a student of math, there's certain things you might want to start avoiding and being careful with. When you write the number 2 and you write z, if you were to write those side by side, do they look different? Does your handwriting look different? Or do your 2's and z's look the same? Okay, if your 2's and z's look the same, then what you should do is what's called striking your z. Anytime you have a z, you strike it, so you know that it's not a 2. It's just a good habit, because if you start having 2's and z's all over the place, you forget what's what. It's over, right? Game over at that point. So just strike your z's. It's a good little thing to pick up on. Okay, have fun. I'm going to pause the video, kick the lights up, give you a few minutes on this. All right, so far we have those 2 properties that we added today, and now we're going to add two more. Actually, there will be 3, but I think what I'm going to do is just do 2 at a time here, or these 2, and then I'll throw the last one at the end. The next one's called the quotient rule. So I'll put the rule on the side here. And then below this, I'm going to put quotient to power rule. So 2 new rules. We'll call them rule, what, 6 and 7? All right, the quotient rule. Does anyone know what the word quotient means really in math? Divide, right? So it's the rule for dividing, okay, for dividing exponents. And here's what it says. I'm going to need a little more space. Sorry, I should have given myself a little more room. The rule says, let's say you have x to the n. Now, don't write this down, but watch what I do here real quick. We have a rule for that, don't we? We have x to the n times x to the m. Same base. What did we do to the powers? You added them, right? You added them. That was from last time, right? Last class. That's what we did. We multiply if it's a power to a power. So that we would add. That's a product, isn't it? This rule is about a quotient instead. So instead of that x to the m being up top, this rule deals with what happens if x to the m is being divided, not multiplied. So what do you think it'll be? Subtraction. Exactly. It'll be subtraction. Now, subtraction of what, though? So let me write it down. It'll be the n on top minus the m on the bottom. That's what it is. I would like to do a couple of examples of that before I give you the next rule. Maybe just 1 or 2 of these. What is 2 to the 4 over 2 to the 2? Well, do we have the same base? 2 and 2? We have a power up here, which is like the n on top, and then we have an m down here. So according to this quotient rule, this should be 2 raised to the 4 minus 2, which is 2 to the 2, which is 4. Y'all see that? Next to this, I'm doing another example. How about y to the 7 over y to the 4? What's that? y to the third. So what you're doing is you're going y to the 7 minus 4, which is y to the third. So if we have the same base, we subtract. Yes. If you don't have the same base, then you have to leave them alone. Just like if we had x and y's next to each other, we can't really put them together, we just leave them. This all right? I'm going to do another problem. Now that looks complicated, but what we're going to do is we're going to kind of break things up. Let's look at the top first. Can you put anything on the top together? Like, can you combine any of those? No, because they all have different bases, right? The bottom, same thing. They all have different bases, so can't do that. But if you kind of squint your eyes enough, you see there's multiplication between everything there, right? And if you draw kind of an imaginary line down where those dots are, each one of those columns is kind of its own problem, isn't it? And that's the way we're going to deal with it. So if I wanted to be really, really anal about this, I could write out the 3 separate fractions that I'm working on individually. You don't have to do this. I'm just trying to help you see it. I'm going to do 3 separate problems. Each one of those is like these above. So look at that 5 to the 10 over 5 to the 7. What does that become? 5 to the 10 minus 7, which is 3. I'll do that on the next line. Times, what does the x become? X to the 3 minus what? 1. Now the 1 comes from the fact that there is a 1 on this x even though we don't write it. So I have to subtract that and keep count of it. What about the y though? It's 1 minus 1. Good. Because there's a 1 on both those y's. Now you might be looking at that y over y is really going to turn, it should turn into what? 1. They cancel, don't they? But see, this property is going to show us the exact same thing. Because what's 1 minus 1? 0. And what's anything to the 0? 1. We said that earlier. So it is going to turn into a 1. So let me write my final thing here. I have 5 to the third, x to the what? Second, and then, well, y to the 0, which it's not going to be there on my final answer, is it? So here's my final line. What is 5 cubed? 125, x squared, and then y? It's gone. It's a 1, so I just leave it off. So my final answer is 125x squared. All right. No questions? The next property, quotient to power rule. So I'm going to write something up here. Okay. You know what? I'll flip back. We have quotient to power, right? A quotient raised to a power. Quotient is a fraction, right? Division. I have division to a power. If we look back in our notes, we had a rule for a product to power. Now we're doing quotient to power. So property 4 was product to power. That was where we had 2 things inside there being multiplied. What did we do? We applied the power to each one, didn't we? Well, it turns out that with the quotient to power rule, it's exactly the same. If you take a quotient or a fraction and you raise it to a power n, then all you do is apply the n to both the top and the bottom. So it becomes x to the n, y to the n. So each one of the factors in the numerator and denominator, each one gets raised to that power. And you're ready to roll. So I think we should put this property into action. Do you have a headache yet? How about 5 over x to the negative 2? Now, do you have a quotient? Yes? Is it being raised to a power? Yes. So according to the rule, I should be able to take the top, whatever's in the top, and then raise it to what? Negative 2. So let me take the 5 and raise it to negative 2. And then I should be able to take the bottom, which is an x, and raise it to negative 2. This is going to be a little bit tricky. Yeah, let me see. What is 5 to the negative 2? We don't like to leave it as 5 to the negative 2. What does 5 to the negative 2 become? 1 over 5 squared, right? Now, this is the first time this has happened in this class, so please pay attention to what I'm about to say. Whenever we have a negative exponent, right, we said we drop it to the bottom, right? It comes down, there's a 1 on top. But this is the first time I've given you a problem where we have a negative exponent, and where is it? On the bottom. Well, guess what happens if it's on the bottom? It goes to the top. So if it's on the top, has a negative exponent, you drop it. If it's on the bottom with a negative exponent, you bring it up. So they basically flip positions, and the negatives become positives on the exponents. So I'm going to take the 5 to the bottom, make it squared. I'm going to take the x to the top, make it squared. Bottom one came up, top one came down. Now, on the top, x squared, you can't do anything to it, right? But what about the bottom? 25. So the answer is x squared over 25. All right, let's try this. How about 9y to the negative 2 over 3x to the third, all of it raised to the third. It's like a snowball, right? It just keeps getting bigger and bigger and worse and worse. Okay, first of all, does everybody see that we have a quotient to a power? Right? We have a quotient to a power. Now, inside there, inside the yellow, can we do anything on the top to put them together? 9 and y squared? Or y to the negative 2? On the bottom, 3 and x cubed, can we put those together? No. There is something we can do. We don't have to, but there is something we can do between the top and bottom, though. What's 9 divided by 3? It's 3, isn't it? I could, if I wanted to, work that out first. So I'll take a vote. How many of you want me to do 9 divided by 3 and just turn it into a 3? No? You just want to leave it as is and just go with it? I'll just go with it. It doesn't matter. It'll work either way. Okay? So I'll just leave it because maybe that's not something you would have naturally done. All right? So I'm going to leave it. Now, since I have a quotient to a power, do you agree with this step? Quotient to a power says I can take everything on the top, raise it to the third, everything on the bottom, raise it to the third. Isn't that what the quotient to power rule says? If the top is like an x and the bottom's like a y, then I take that x and I raise it to the third, the y to the third. Separated. No? if I have x to the y, or sorry, x to the y, x over y to the n, this is what the property says, right? So if x is some blob of junk there, and the y is some blob of junk there, then the property says just take your junk on top, raise it to the n, take your junk on the bottom, raise it to the n, right? So my junk over here is everything in here. That's my x. Everything in here is my y. So all I'm going to do is I'm going to take that x, raise it to the third. I'm going to take that y, raise it to the third also. Each one of them. Now, each one of them is its own unique little pain in the butt problem, because that's 9 to the negative 2, and this is 9y to the negative 2. This is 3x to the third. Do you agree with that? So this and this are like the x and y in the formula. Okay. Now just take a breath. The numerator, forget the denominator. Numerator, what property is that? That's a product here, isn't it? To a power. It's two things being multiplied to a power. So how do we deal with products to powers? We apply the power to each one, right? So I'm going to do 9 to the third times y to the negative 2 to the third. So all I did was I grabbed the 3 and applied it to the 9 and to the negative y to the negative 2. So I'm using my product to power property on top. Have y'all ever seen an airplane disintegrate in air? Like, have you ever seen an airplane come apart? Like when it's flying? I mean, not with people in it. I'm just saying, like, have you ever seen like a drone or something like that where like the wing becomes unstable and fails, and then it breaks away and then it starts tumbling, then the whole thing just disintegrates? I don't know. That's kind of the look I'm getting from some of y'all right now. Like, y'all, everything's been okay, and then now the wing's starting to shake, and things are starting to fall. I'm just hoping that hoping the structure holds here. It's a lot. It's a lot because the properties are very, by themselves, in a very simple example, they are pretty easy to follow. If I just give you like quotient, like this quotient property, if I just do, like 1 over x, and then I say square, then you can square the top and square the bottom, and then it's pretty clean and pretty easy to follow that. But when you have to combine it with all these other properties, then things start to get messy. Practice is what makes you good at this. All right. Sorry, I'm going off on a tangent. What can I do on the bottom? What property do I have here? It's product to power again, right? So I'm going to be able to take that power up top, the 3, and apply it to the 3 and to the x to the third. So it'll be 3 to the third, right? And then it'll be, in parentheses, x to the third again. Whew, okay. Man, we're almost out of time. What the heck? Yeah, it's so much fun. It just blows right by. 9 to the third. 9 times 9 times 9. 729. Calculator for that. Maybe the 3 would have made it. It would have made it a lot easier, but it's okay. It's okay. What is the y to the negative 2 to the third? What property is that? That's right. It's negative 6, and that's the power to power property, right? If you have something to a power, so y is raised to a negative 2, and then you raise that whole thing to a power, we're going to multiply those two powers together. So we're multiplying those two together to get negative 6, y to the negative 6. On the bottom, 3 cubed, 27, x cubed cubed. That's a power to power again, isn't it? So that'll be 9, right? X to the 9th. Now, I believe 729 divided by 27 is 27. So I'm going to turn this right here into 27 off my calculator. Uh-oh, 27's all alone up top. Why? The y to the negative 6 doesn't like to be negative, it likes to be dropped down. And it likes to join the what that's still down there? The x to the 9th. And then next to it is y to the positive 6. Now all exponents are positive. Everything's been multiplied out. We have arrived as scattered debris in a field somewhere, cornfield in Oklahoma. No. Does it what? Crazy. I haven't said anything crazy yet in this class. Not yet. Are y'all all right? Okay, so the only way you're going to actually get good at this, you're going to have to practice. Was that a question? Or stretch? Ah, you remembered. The sign-in? Yeah, you get bonus for that because you remembered. See, I always forget. I get all excited about doing math. Okay, what was your last name? Say it again. Oh, okay. Well, let's figure that out. Just come up here when we're done, which we are done. Here's what I'd like for you to do for homework. Oh, man. Still skip that 1 through 6. Just come back because we still have one more property to talk about. I'm going to have to take a little bit of time in the beginning next class to talk about that. So first 15 minutes of class next time will be last rule, and then the rest will be review for the test. Let's look at page 346. We stopped at 26. Let's try 27 through, unfortunately, everything in here is good practice. So I'm going to stay through 51 odd. That's a lot of work. Just the odds, though. If you have time, go do the evens, because that's just more practice, the better. I believe we're done. Oh, no, I need to sign in. I'm going to have to call names. Let me do it that way. I call you, you can go. Let me pause this or stop this.